You might be surprised to know that a lot of energy is wasted every time you turn on a light. How do you know? And where does it go? And wouldn't it be great if you could recycle that wasted energy just like we recycle used plastic bottles? Hi, my name is Kristen Constant, and in my job as a materials engineer and a professor at a university, I'm working to answer these questions. When I was a student in school, I really liked using math and science to solve problems. And so when I went to college, I decided to study engineering because that's exactly what engineers do. They take difficult and very important problems and use math and science to come up with solutions. When people have a question, they often ask engineers to help them figure it out. These days, I'm trying to answer the question how you can make a light bulb more efficient. Not much has changed in the 125 years since Thomas Edison first invented the incandescent light bulb. Light bulbs these days still use electricity. That electricity heats a filament that's inside the light bulb, and that filament is what produces the light that we see. However, all lights from the first electric light bulbs to today generate a lot of heat. How do you know? Well, if ever you've gotten too close to a light bulb, you know that it generates a lot of heat. In fact, 94% of the energy that goes into a light bulb actually comes out as heat and not light. That's like taking every dollar you have and throwing away 94 cents and only using 6 cents to buy what you want. What if we could find a way to change the light to get rid of that unwanted heat and still light our homes and schools? My job is to figure out how to change that unwanted heat back into light. This is where it gets very exciting because no one has done this before. And if we're successful, we can save a lot of energy and money. And of course, producing energy costs money, so with the money we save, we can buy other things. Also, generating electricity actually is hard on the environment. So the less electricity we use, the less harm we do to our environment, and the better it is for our checkbook.
How things are going?
When my team and I were thinking about solving this problem, we thought, wouldn't it be great if you could recycle this light and use it again, just like we recycle used bottles and cans? But in order to do this, we need to figure out a way to change the light so that it produces less heat. You may not think about it, but you change light in your life every day. One way to look at it is first think about a light source, whether it's a regular incandescent bulb or the sunlight. When that light hits a material, it's changed. How is it changed? Well, one way it can be changed is by reflection. Reflection is when we change the direction of a light using a shiny object. For example, this hood on this light keeps the light moving forward instead of going in all directions. Another way we can change light is through refraction. Refraction is when we change the direction of light, as you do in this magnifying glass. So for this flashlight, you can see that the light is fairly diffuse and spreads out. But with the magnifying glass, it's concentrated on one spot, and that's through refraction. Another example of a way to change light is absorption. And a good example of absorption is the tinting that they put on car windows to keep too much sunlight from getting inside and heating up the interior of your car. Just like you use materials to change light in your everyday life, our job is to change light that comes out of a light bulb. To do this, we make tiny, tiny filters that go on the inside of a light bulb. They allow the light to escape the light bulb, but not the heat. The energy that was wasted to make heat now can be used to make light, and the light bulb is much more efficient. You can see the way this filter changes the laser light. However, we're trying to make a filter that changes incandescent light. The problem we're having is it's very difficult to make this filter small enough. We've tried lots of different things and we're making good progress. We're hopeful that we can come up with a solution very soon. You might wonder, why would we want to change this light so we can recycle it? Well, energy use is a big problem to solve. We use a lot of energy in our country and around the world. Think about all the lights around you. Even in the daytime, we have lights on in our schools and homes and offices. If we can save a lot of the energy we use for lights, we can save a lot of money and help the environment. What a great combination! I like working on problems like this one because it's very exciting for me to think that I could help find the solution that helps my friends and neighbors save money and save the environment at the same time. Also, I get to work with engineers around the world who are working on this problem. You can ask scientific questions about light too. Try to change the light and predict what will happen. All you need is a flashlight and a variety of materials. Before you shine the light on the materials, ask yourself, will this material reflect, refract, or absorb the light? Once you've made your guess, point the flashlight at the material and see if you were right. Did the light do what you thought it would do? If not, take a good close look at the material and try to figure out why. Better yet, think about what you can do to change the way the material behaves. If you do that, if you think about why things happen and how you can change it, you're thinking like an engineer.